Okay, we're looking at problem 5.52. You see it's a giant swing thing. It's going around there. And basically you can see the person sitting on the bottom right. They're swinging around in a circle. And there is a part of the arm that is horizontal and part of the arm that's diagonal. So let's draw a free body diagram for it. Here is the point. Okay, we've got mg down that way, and we're going to have some kind of tension that way. Sorry, this thing is not very centered. So, okay, okay. All right. And we know that in this case, you see mg is a vertical force, so it's not going to be the centripetal part. So that means that, and this angle, if I remember right, is like 30 degrees. I'm not going to be able to write that in here. Okay. And what that means for us is that Ty minus mg is going to equal 0 because it's going to be balanced in this direction. Okay. And that Tx is going to equal ma sub c, because that's the part that's going to keep it going in a circle. And because this time we want the period of it, we're going to replace it with a m 4 pi squared r over t squared. It's going to get us the closest to the period that we want. So let's start by finding what the tension is. Well, let's start with this part here. We're going to have to put these two things together, I think, to actually divide it out. So let's start with the ty on top. Ty, since the y part is the it's going to be the cosine of that angle, so it's going to be cosine theta. Whoops, not theta. Let's make that 30 degrees, so we know what the angle actually is. Minus mg equals 0. Okay. What that means for us is actually pretty nice. It means that t is going to equal mg over the cosine of 30 degrees. Okay. Cosine of 30 degrees is what, root 3 over 2. So that's going to be mg 2mg over root 3. So that means that when we have that, we can replace that. And that's not terrible. Okay. So we're going to do the same thing with the other equation. So we're going to take sine equals m4 pi squared r over t squared. And we can replace that. So you can see I moved everything up top, and I kind of invented a problem for myself because I have a T for tension and a T for period, which means I need to get rid of that T up on the top left as quickly as I can. So let's replace it with the 2mg over root 3 that we had from the last time. The sine of 30 is just 1/2, so we're going to replace that with 0.5 equals m4 pi squared, okay, r over t squared. I want to point out that I've sort of avoided replacing r. The reason is because r is complicated. R is the distance from there to there, okay? And that's not 3. Okay? The distance is actually going to be what? It's going to be, r is going to be 3 plus 5 times the sine of 30 degrees, which is going to be 3 plus 2.5 or 5 So we actually kind of know that already. So, and before I put that back in, I'm going to divide out these m's because I don't need them. Hey, nice. And the 2 and the 0.5 are going to go away. So I'm going to have g over root 3 equals 4 pi squared times 5.5 over t squared. Okay. Now I'm going to rearrange everything. So I'm going to have t squared equals root 3 times 4 pi squared times 5.5 divided by g, okay, which means that period will just be the square root of all that stuff. Okay. So I'm taking out my calculator right now. Let's try it out. Okay, so root 3 to the 0.5. I just like that way better. I remember it quicker. Okay, that's 4 times pi squared times 5.5 divided by 9.8. Twice on accident. So try it again. 4 times 0.14 squared times 5.5 divided by 9.8. Okay, so 38.2. I take the square root of that. I get 6.19 for the time. Okay. All right, so 6.19 seconds is the amount of time that it took. Part B says, does the angle depend on the weight of the passenger for a given rate of revolution? You can see that up here, we actually divided the mass out. Okay. Okay. So we didn't, so you can see that, you know, you put, assuming whatever weight the bar can handle, okay, as long as we don't bend or deform the bar, we're not going to get any change in what the tension is going to be, or any change in those masses dividing out. So it's not going to make any difference in our answer.